Hi everybody, and welcome to my presentation on measuring performance and capacity planning in Java-based data grids. Let me start by introducing myself. My name is Mircea Markus. I've been working for JBoss and Red Hat since 2007. I've been mainly involved in the JBoss clustering stack, projects such as JBossCache and JGoups. Starting with 2009, I've been working on the Infinispan project, which I currently lead. I also started a project called Radargun, which is a tool we use for benchmarking the performance between our releases and also comparing ourselves with the competing projects. It's an open source project, and it's the project I'm going to discuss about today. I'm also an expert group in JSR 350, which is state management, Java state management, JSR. My presentation today will cover what in-memory data grids are, so basically what we test. Then we'll briefly introduce Project Radargun, which is the tool we use for testing. The challenges, we'll discuss the challenges we had when trying to test, and also some features of Radargun. So first things first, what are in-memory data grids? In-memory data grids are distributed data management system which primarily holds and stores the data in memory. Why in memory? Well, memory is cheaper and cheaper, but it's still more expensive than disk. The reason for storing data in memory is for having fast access to data. So it's not, you wouldn't generally store a huge amount of data in memory, but only part of the data, and namely the data you need fast access to. Such a data grid stores data in multiple processes, which are normally called nodes. Here we have 3 processes which communicate over a network, and they form a cluster. The total storage capacity being the sum of individuals' node storage capacity. Normally, the data is stored with more than one copy, so redundant copies of data are stored in memory data grids. The reason for doing that is to achieve a certain degree of durability. Also, the in-memory data grids may be configured with a more durable alternative storage, such as a database or file system. That's needed, for example, when you need to stop the system for maintenance, and you just want to preserve that data, so you flush it somewhere so that you can load it when you restart it. There is a standardization effort around data grids. That's because multiple projects and more projects in this space started to have similar features. That is JSR 347. It hasn't been released yet. Actually, it has started 2 years ago. It is led by a colleague of mine, Manik Surtani. API-wise, data grid products expose a map-based API, no formal way of expressing the schema. They are generally built with horizontal scaling in mind. What do I mean by horizontal scaling? It means adding more nodes to the grid increases proportionally the storing capacity and also doesn't decrease the performance. Few other things, consistent hashing is a technique commonly used for scaling. And also, data grids are, they have high availability in the sense that when a node joins or leaves, the user can still connect with the grid, and there's no stop the world happening. From an access pattern perspective, there are 2 major ways of accessing a data grid. First one is embedded. In the embedded mode, both the client and the server live in the same virtual machine. The communication is faster than than the other mode, which is the remote mode, because you don't have to serialize nor to deserialize the objects. You persist in the grid. Generally, the embedded mode has good support for transactions, or XA transactions even. But the embedded mode is not always good enough. For example, when you want to consume or access the grid from a client that's not Java and the grid is written in Java. So generally, the data grid products also come with a client-server access pattern, which is a bit like the way the database is, or a database server is accessed. You have clients opening TCP connections to it, running queries, so on and so forth. The remote access is normally functionally the embedded clients can take or make more use of the grid. Like things like transactions are not as well supported for remote clients. Just as a side note. These are some of the in-memory data grids I'm more familiar with. By no means all of them. They have been around for a while. For example, one of the pioneers, Oracle Coherence, I think it has been around for about 11 years now. So there are some open source solutions such as Infinispan, EHCache, Hazelcast, and some other solutions, commercial solutions, Coherence, Gigaspaces, Genfire. As a side note, Red Hat, Red Hat has professional support for Infinispan that has been around for a few months now. It's called JBoss Data Grid, JDG. So why Radargun? Why did we came with Radargun? Because generally it's benchmarks or writing benchmarks and running benchmarks can be a problematic issues. There's always a discussion and a long debate when it comes to running benchmarks and analyzing the results. Well, one of the main reasons for us internally was that, as a library developer, you don't really want to end up with, 50% regression in performance in some very usual or very common access patterns. So that was a problem for us, and we really wanted a way in which to check performance regressions between our releases. So we started writing this internal tool that helped us, just launch few nodes there, run some benchmarks, and just give us an idea whether we are on the same or we didn't lose performance between releases, ideally to gain performance. Another reason is the fact that benchmarking a data grid is not as trivial as benchmarking a thing that runs on a single process. And by that I mean, you have to start multiple nodes at the same time, make sure that you run the benchmark at the same time, that might be multiple processes running on multiple machines. And I'm not talking about 2-3 machines here, I'm talking about 60 machines or 100 machines, and you want a way to automate that. And after you run everything at the same time, you want to collect the results somewhere and produce some nice reports. So that was another reason, just to be able to not only to run a benchmark, but to do it fast. Of course, we wanted to see where Infinispan is compared with our competitors performance-wise. And I think and one of the most important features or reasons for having Radargun is the fact that you constantly, myself as an Infinispan developer, I'm constantly asked how fast Infinispan runs, and that's not really a question I can answer to. So the honest answer is why don't you try it yourself and run it, see if it fits your use case, analyze the results, and perhaps compare it with some other similar products. Radargun being an open source project, you can just use it and, write your own access patterns and see if it fits you. So we build it so that it is easy to write plugins for it, both plugins for different products and plugins for checking or for emulating the way you will access the grid, and it's easy to run it. Right, so that's pretty much what I've been saying. It's easy to extend. Generally, we come with some predefined access patterns. For example, in-memory data grids are heavily used for web session replications. JBoss under the hood uses either, depending on the version, either JBossCache or Infinispan. Same for the other data grids I've mentioned. So one access pattern we emulated through Radargun is the web session replication. We have other access patterns which, just something like do 50% reads, do 50% writes, just to get an idea. But the good thing is you can easily plug your own access pattern. There is an interface you extend and just access and stress the grid the way your application would. And that's really good if you want to write a proof of concept, just to see whether, okay, the grid will give the performance I need from it. Also, when it comes to extending it, right now we support a set of data grid implementations, but we made it in such a way that you can add implementations for other data grids. So we started with JBossCache at the time, then we added Infinispan, we have Coherence, EHCache, and there are some others, but you can also, well, if you want to compare it with another proprietary solution perhaps, or whatever solution you consider, you can add a plugin to that for that as well. Few words on how Radargun works. This diagram shows three nodes, potentially three different processes, a benchmark running on three different processes. Normally we run it on it's a much larger scale, 60 processes or more. But you can run it with a very high number of processes. We run, well, the highest I know being run with is about 150. So the way it works, you start a grid node in all these processes, and then you wait for all the nodes to start. You see there is a synchronize that basically the Radargun coordinates for the grid to be started on all nodes, because you don't want you don't want to start benchmarking when only one node was started. You want to start benchmarking when everything it's properly set up. Then another stage is we make sure that the cluster is correctly set up. I mean, even if you started a node, there's no guarantee that the given node has joined the cluster already. So we do make sure that the cluster is properly formed before proceeding forward. So after the cluster is formed, we run a warm-up. What's the reason for doing that? Well, we want the result of the benchmark to be as close as possible with how the application would behave in real life. So we want to allow the garbage collection to kick in, or the hotspot to kick in. So you can specify time or a number of operations for warm-up. You can say, okay, just let it warm up for 1 hour. At that point, you might be quite confident that the hotspot has kicked in. Or you can enable the hotspot, the compiler, the hotspot debug information, so that you can see that at one point the hotspot doesn't kick in anymore. That's a good time for warm-up. After the benchmark, or after the grid is warm up, we clean whatever the warm-up placed in the grid, and then we run the actual benchmark. And this is the phase we measure. As we'll see, we measure quite a few things. It's not only the performance per se, because you might be interested in performance, but there are other things you might be interested in, like memory consumption, CPU consumption, And we track this as well for the whole duration of the benchmark, and we can present it to you in a report. After the benchmark is, so the benchmark runs in parallel on all nodes at the same time. So it starts at the same time and it ends at the same time. After the benchmark ends, we gather all the information from all nodes, we place it in a central place, and we generate reports. This is the configuration file, and I think it shows a bit how to configure, and also it shows a bit the functionality behind it. So this is pretty much all you can, all you need to configure in order to run a benchmark, provided that the product plugin is written and the data access plugin is written. The first line, the master, we configured the, when we run these benchmarks, we delegate a node that kind of coordinates between the nodes in the grid, and that would be the master. I won't go into too many details about it now. The second part is the benchmark. You see we configure an initial size, that's the initial size of the cluster, and then maximum size. So it starts from 2 and it goes up to 4, 4 being also being the default value, but you can specify another value there by a system property. What does that mean? It means that the benchmark that's described in the benchmark element will be run on 2 nodes, 3 nodes, 4 nodes, and up to, I don't know how many nodes you have configured. And the increment is the number of nodes to be added to the cluster at any given point. For example, if you run a benchmark on 100 nodes, you might not be interested to see how the benchmark behaves at every increment of the cluster. You might run it with 5 nodes, 10 nodes, 15 nodes. You don't necessarily want to see how it behaves with 6 or 7 and 8 nodes. You just want to increase the cluster at a higher rate. So what we do here, we destroy whatever was running before, we start the cluster, we validate that the cluster was formed successfully, then we run the web session, the warm-up for the web session replication test. We specify some properties for it. After the warm-up is finished, we make sure that the cluster is cleared. Then we run the actual benchmark, and then we generate the report. So this is the benchmark element describes the test and what test we will run. Now in the products, we specify what products we want to compare. So this benchmark will be run for each product specified in the products element. So basically at this stage we want to compare JBossCache 3 with Infinispan 4, but you can come up with different products as well. And then is the report generation part, in which you specify what reports you want to have generated. This would be PNG files and CSV files, but it's much more flexible than it looks here. This is just a generic report. Basically, all means just include everything in a single report. I've mentioned that one of the reasons for having Radargun was the easiness of launching the benchmark. So we do that through several SH scripts. So benchmark SH just runs the whole cluster, connects to all the nodes, just tells the process to start. It parses the XML file I've showed in the previous slides. Chart SH means that once you have the results generated, you might generate some other comparisons or some other graphs based on some pre-generated results. This SH, this is, it was a lifesaver for us at one point, and I think it's quite cool. What it allows you to, or what it shows you is the load on each node of the cluster. What you don't want, for example, when writing things to a data grid is you don't want one of the nodes to have half of the data in the grid and the other 20 just a small bit of it. Ideally, each node should have the same load. And what this SH does is it shows you how, or the share of data each individual node holds. which ideally should be even. Each node should have even number of elements after a benchmark. Local SH, well, local SH is for benchmark. It does the same thing as benchmark SH, but for local caches. There is a standard. Well, there is a standard on its way. Actually, it has been on its way for the last 10 years. It's JSR 107. It's an effort to standardize the local caches, not the data grid. Data grid being JSR 347 tries to take this to a new level to standardize data grids. So you can also benchmark 107-like caches and see different performance reports with local SH. A few benchmarks we have. I've mentioned web session benchmark. Well, I think it's the one we use the most. It's mainly because it's one of the key, well, the session replication is one of the common or classic use case for in-memory data grids. The thing with web session benchmark is that there's no contention, so you don't have at any point two transactions writing on the same key set. It's quite configurable. You can configure the number of requests, the write percentage, the size of the session you manipulate. But if you want to see how, or well, that's more of a generic benchmark, to test how the grid behaves under concurrent access with multiple transactions writing to the same key set concurrently, we have a TPCC benchmark that's for transaction processing performance consortium, something like that. It's a standard benchmark it's used for databases. So if you see a database is faster than another, normally it's the TPCC that's being run for databases. So it basically emulates the same benchmark but for data grids. It has been contributed by CloudTM project. is a European Union founded project they do look very carefully at transaction performance in distributed systems. So they use that for, and we started using it. They use that for checking different transaction protocols, how they behave under different levels of contentions. But of course, the nice part is that the benchmarks are pluggable. So Radargun can be used as a tool for writing proof of concepts quickly when it comes to data grids. Otherwise, it can be a bit of a pain to do that. So you can just extend an interface and add your own access pattern to be as close as possible to how your application would end up using the data grid, and then just see performance and decide whether it fits or not. We've also started using Radargun for resilience testing. So that means you start with a cluster of, for example, 30 nodes, and you gradually increase the cluster size up to 60 nodes, and then decrease it. And what do you want to measure during that time? Well, how long does it take for a node to join the cluster? You want to see how the cluster behaves when a node joins, because that normally involves a state transfer, and there's an extra stress on the cluster. So generally the performance degrades when nodes are joining or nodes are leaving. And very important, you also want to see that if you add a node or a node leaves, a node crashes, data is not lost. So that's tested as well. That's the correctness, the behavior correctness during resilience. Just to give you an idea of the kind of reports generated, so on X we have the number of nodes, 4, 6, 8, 10. And on Y, we have the number of transactions per second. So it gives you a good idea on how the grid scales when you add more nodes or when you remove nodes from it. is not a very realistic scenario, this one, but just to give an idea on the performance results it generates. Also, this one shows on the x is the number of seconds. Again, you don't normally run at a benchmark for 75 seconds. You do that for half an hour, or even more than that. So basically what this shows is the memory variation during the entire execution of the benchmark for two products. This is the same as the memory one, but with CPU usage. This is the list of plugins we currently support: Infinispan, JBossCache, Coherence, Cache. We have a plugin for JGoups, but again, as I've mentioned, it's very easy to add your own. You pretty much only need to implement an interface. There's the cache wrapper with two methods to set up. There's to start the cluster, another method to tear it down just to clear up the resources you allocated, and then put, get, and empty. It's an open source project, as I've mentioned. You can find it on GitHub. I'm the maintainer of it, but the plan is to involve more people, and we already have some contributor that will start to look into it in more detail. So that's pretty much all from my side. Thank you for attending the presentation. It's quite late. If you have any questions, we still have 4 minutes for it. So.
Would the result be relevant if I run this on the development hardware? Because I'll probably don't have access to the production hardware. Or how would it?
Right. Well, it's really, that's one of the reasons I don't want to give numbers when I'm being asked how Infinispan behaves under certain, because it depends on so many factors, like the hardware, the access patterns. Ideally, you'd want it to be run on the kind of system you would use in production, just to get an idea of if it solves your problem performance-wise or it doesn't. But generally, I think you would use, the hardware you'd use in staging is not as good as the one you use in production. So you can get some information from it, but ideally you should use the same hardware, I think. Other questions? Thank you very much. Enjoy the conference.